Hey YouTube, this is a tutorial about linked lists in C++. So I kind of, just for time's sake, already prototyped it out a little bit. Just really simple iostream string. So I already made the class, and we're just going to go through that for a second. I have it's a class named list, right? We have these private items right here, string to hold names, and this is basically just going to be a program that holds people's name, really in no particular order, basically just first in, first out. So we have a list pointer next node and list pointer root node. And what this one's going to do is this is going to point to the next item in the list. Okay, and don't worry if you don't understand that quite yet. When we actually program it out, it'll make sense. And this is a list program or pointer to the root node. Now the root node is the first item in the list, and it is, for this tutorial, unchanging. It is basically the first item in the list, and we need it to traverse the list. And so this will be the first one, and then just string name. Obviously this is going to be someone's name we're holding. Now we have this default constructor. If you've never seen a constructor before, you don't really need one, although it is easier just to set next node to null for every new instance of the object list that we create. So it's easier to do that. It's easier to set this to null. You don't really need it though. You could code it. It would be extra coding though, so I don't know why you wouldn't use it. This is what I may or may not have time to get to in this tutorial, depending on how much time I have. This is a destructor, and you definitely, really need one. If you don't have a destructor, you will get a memory leak. And that is a bad thing because it takes away performance, and it also makes babies cry. So we need to do a constructor, and if I don't do it in this video, I will definitely do it in the next video where I talk about why you would use a linked list and some more of the concepts of this really basic abstract data type. So let's just go into one of our first function, which is add name. This is going to add a name to the list. So what we want to do is we want to make two list pointers. Excuse me. We're going to call one travel pointer, and it doesn't matter how I spell it because I do what I want. And we're going to have one called current pointer. Yep. And like I said, you can spell it however you want, because I'm a gangster. So every time we drop into this add name function right here, we're going to make current pointer a new list object. Okay. So yeah, this may be different for you. I know when I first learned about LinkedList, it was difficult to understand, basically, because I was so used to naming my variables like string name, and it was so difficult for me to understand that you could pop in and make current pointer a new list object every time, and then without using a naming to find it using pointers and traversing the list. I'm not really doing a great job of explaining that, but since this is a free tutorial, you do get what you pay for. So this is how we make current pointer every time we drop into the add name function. So let's go ahead and just go ahead and just C in the name right there, and enter a name, current pointer name. So there we go. That's how we assign value to this current pointer we just created every time we drop into this add name. Now we get to the part that's really the meat and bones of it. And what we're saying here is if root node equals null. Okay, so we're saying if root node doesn't have a value, there's no first item in the list, then this one that we just entered, this name we just entered, is the first item in the list. So we assign root node the value of current pointer. Pretty simple. Now, if there has already been items in the list, we're going to use travel pointer. And when we're saying travel pointer, we're going to set to equal root node. Okay, and I'll explain about that in a second. And we're going to say while travel pointer. So what we're doing here is we're basically saying travel pointer equals root node. Okay, so we're setting travel pointer to the first item in the list. And then we're going to go through the list, we're going to traverse the list until we get to the end of the list. And we do that with this while loop. And every time that travel pointer's item that it's pointing to, its next node, is not null, then we're going to make travel pointer its next node. So in that way, we're saying, oh, is it no, okay, then it equals that, until it gets to the point where it's at the end of the list, and then we can tack current pointer onto it. So we say now that the next node is at a null position, we can attach current pointer. Yeah, I mean that's pretty simple here. The reason we can't use root node is because we're changing travel pointer here to get to traverse the list. Now, if we were to change root node, we would lose the list, and it would only hold one item, and it would be really error-ridden program. It would suck. It would not be a linked list. So that's it. Now we're just going to go into the show name function, and it's pretty simple as well. And we're gonna have some of our old buddies back. Travel pointer again. Oh, I might want to make it a pointer. And there we go. And we're just gonna say travel pointer equals root node. And we're gonna say wow. We're gonna say while travel pointer is not equal to null. Now up here we did while travel pointer next node, because we're trying to get to the end of the list to attach current pointer to the end of that list. Okay. Here we're just trying to get to the point where it's null, and then it'll stop, c-outing the name. So we're just gonna c-out the name. That would be and then we're going to change travel pointer. After we output the name, we're going to change travel pointer to equal travel pointer's next node. Okay, and that's pretty much it. Let me see if it compiles, and it does. It works. So I added into main here my list, int question. While question is not 3. Enter a name, and if question is 1, we're going to add a name, right? So we'll use the mylist.add. Now remember, we can use the dot operator here because we're not working with pointers. When you're working with pointers, variables such as here, you cannot use the dot operator. It will not work. Yeah, so pretty simple, and let's go ahead and run it and see if it works. So let's go ahead and enter a name. We're going to enter Bob. Enter another name. Sally, and enter another name, Bill, and one more, John. Alright, now let's show our list, and Bob, Sally, Bill, John. So in this way we can use just exactly as much memory as we need. In the last sort of minute about this video, what I'm going to talk about is, why would you use a linked list? Well, because they're a lot better than arrays or vectors for certain things. If you want to make sure that you're only using as much memory as you need to, and not anymore, and also that searching the list is not important to you, then the linked list might be your best bet. But also it's really important too, because without really the fundamental knowledge of a linked list, it's harder to figure out some more of these other abstract data types, such as trees, and it's harder without learning this and learning a little bit about working with pointers, just a little bit. So yeah, actually, and I'm going to go through and let's go ahead and code this destructor as well, because we really do need a destructor. So, okay, we're going to say while so yeah, let's go ahead and code this out, and we're going to have one of our old friends back again, travel pointer, trivial pointer, because I name my variables what I like. There we go. And what we're going to say is root node is not equal to null. And we're going to say that travel pointer equals this root node, next node. Okay. And we're going to delete root node. Say root node equals travel pointer. So basically what we're doing here is, since it's the destructor and it's called at the end right before the program closes, it's okay to use root node because we're just going to be deleting it. We're only using travel pointer as like a placeholder. So what we're saying is while root node does not equal to null. So what we're going to do here is we're going to set travel pointer to equal the next item in the list, starting with the first list. This would be the second item in the list. Then we're going to delete the root node, okay, and then we're going to make root node equal to travel pointer once again, and it's going to keep doing it until it's null, and then it'll all be deleted, because when you use a delete, or excuse me, when you use the new keyword, you must use the delete keyword or you will get a memory leak. And for a tiny program like this, it doesn't matter, but getting a memory leak almost it defeats the purpose of using a linked list, because when you would use a linked list, memory would be probably one of the main factors in why you would be using it. So yeah, that's about it. Pretty simple. It's not too difficult. You can name these anything you want. I mean, it's not really that difficult, but it seems to give people a lot of problems. So stay tuned for my next video. My next video, I'm going to probably share a little bit about, when you would actually use this and when you would use, a different abstract data type. And then the video after that, I'm going to talk about binary search trees in C++. So if you have any questions, go ahead and post it. And thanks a lot, YouTube. Bye.